Hi everyone, I hope you're okay. I'll be doing video number 7, guys, which means I'm doing the 7th question of the November 2022 examination. It's a mathematics paper 1 examination, obviously written by the grade 12 learners. Just note that since this is the 7th video, there are 6 videos before this one, which simply means each question has its own video. And I will have 3 videos after this one. Please click the link on the description below. It will direct you straight whereby you'll come across the link that will take you to the playlist with the full memorandum. And you can download the paper, answer the questions with me. If there are things you're not sure about, please do ask on the comment section. I will definitely come back and answer you. Okay, question number 1. I'm supposed to find the derivative of f of x from first principles if f of x is equal to x squared plus x. So finding the derivative from first principle, I simply need to say f prime of x is equal to limit as h approaches 0. I will have f of x plus h minus f of x all over h. All together. So I have limit as h approaches 0. Remember that f of x is equal to x squared plus x, right? So for f of x plus h, it simply means whenever I come across x, I must substitute x plus h. All together. So I'll simply have x plus h squared plus x plus h minus f of x. F of x is equal to x squared plus x. This entire thing is all divided by h. Are we together? So I just need to remove the brackets now. You'll obviously open 2 brackets and expand here, but you'll end up having x squared plus 2xh plus h squared, and then you'll have a plus x and a plus h minus I'll have a minus x squared and a minus h there, all over h over there. Né? Limit as h approaches 0. I can see that the x squared and this x squared will subtract one another, and the x's will also subtract one another. So I will be left with 2xh plus h squared plus h all over h. And then now I can just take out a common factor of h. Whenever I do that, I'll be left with 2x plus h plus 1 all over h. All right, together. So this will leave me with limit as h approaches 0, 2x plus h plus 1. So now I'm supposed to substitute 0 because I no longer have h at the denominator. All together. It took me this long to substitute 0 whenever I see h, because I had h at the denominator. All together. I don't want to have a 0 at the denominator because the entire number or the entire expression will be undefined. Are we together? So in this case, I'll be left with 2x plus 0 plus 1. Please note that whenever I'm substituting with 0, whenever I come across h, I no longer write limit as h approaches 0. So therefore, my derivative f prime of x will be 2x plus 1. All right, together. So from first principle, I found my derivative to be my f prime of x to be equal to 2x plus 1. Okay, now let's move to 7.2. As I'm creating room to write, guys, I hope you are going to subscribe. It won't take anything, guys. Do tatalento ainabongozi. Okay, I'm given f of x. I'm supposed to determine the derivative of f. Ne? In this case, they didn't stipulate that I must derive from first principle, so I can simply use the rule. Ne? Remember that the rule says if f of x is equal to a x to the power n, therefore to find the derivative, I'll simply take the exponent, multiply with the coefficient of the variable I'm deriving, and then I'll just subtract 1 on my exponent. Are you together? So I'm given f of x to be equal to 2x to the power 5 minus 3x to the power 4 plus 8. I'm supposed to find the derivative. F prime of x is simply equal to 10x to the power 4 minus 12x to the power 3, there's an x there, plus 8. So this is my derivative. Are you together? So f prime of x is equal to 10x to the power 4 minus 12x to the power 3 plus 8. Okay, now let's do question 7.3. 7.3, we are told that the tangent to the curve g of x has a minimum gradient at this point over here. Then we are being asked for which values of x will g be concave up. Okay, firstly we are told that our gradient has a minimum gradient, right? Our tangent has a minimum gradient, right? Okay, since I'm given g of x to be equal to ax cubed plus 3x squared plus bx plus c, né? Okay, the derivative of the gradient of a tangent is always equal to the derivative, to the first derivative of a curve. Are you together? So for me to find the gradient of a tangent, this equation over here, the derivative will give me the gradient of my tangent. Are you together? But I was told that my tangent has a minimum gradient at this point. Are you together? The word minimum simply means that I must derive the gradient that I have. Are you together? Since the first derivative tells me about the gradient, for me to find the minimum gradient, I must derive the derivative. Basically, I must find the second derivative. G double prime of x will be equal to 6a times x plus 6. Are you together? And I was told that I will have a minimum gradient when x is equal to 1. So for minimum gradient, please note that the g prime of x is equal to 0. G double prime of x is equal to 0, right? So I know that my second derivative will be 0 if and only if the value of x is negative 1. So now I have only one unknown, which is a. I can simply solve for a. So negative 6 is equal to negative 6a. Divide both sides by negative 6, then a is 1. Are you together? So now I do know the value of a. I can simply use it to answer the question. Remember that g of x was equal to ax cubed. The value of a is 1, right? So I'll say x cubed plus 3x squared plus bx plus c. Ne? I was asked for which values of x will g be concave up. G will be concave up if the second derivative is greater than 0. Are you together? So g prime of x is equal to 3x squared plus 6x plus b, ne? And then my second derivative is simply equal to 6x plus 6. So for the graph of g to be concave up, the second derivative should be greater than 0. So I will simply say 6x plus 6 is greater than 0. Then 6x is greater than a negative 6. Then x has to be greater than a negative 1. Are you together? So to answer that question, the graph of G will be concave up when x is greater than a -1. That's how, guys, we could have tackled this question. I really hope that, guys, the video helped you out and you gained a lot. Thank you very much.